Hello everyone. Today we discuss about optics. Objective of the today's class: able to understand the properties of light, Michelson interferometer, the theory of average applications. Introduction. Optics is a branch of physics which deals with various basic properties of light such as reflection, refraction, interference, diffraction, polarization, dispersion, etc. We know the light has dual nature. It can behave both as a particle and as a wave nature. The wave nature of light is proved by the phenomena of interference of light. Using the principle of interference, one can design the anti-reflection coating element used in cameras, telescopes, etc. The phenomena of interference is also used to study the formation of colors in soap bubbles, thin film of petrol, diesel, etc. So before going to detailedly discuss about the optics, we have to understand some basic concepts like reflection, refraction, interference. In that first one, reflection, when a light wave passes from one medium to another medium and if it turn back to the same medium is called as reflection. Laws of reflection. First law state that the incident ray, the reflected ray and the normal at the point of incidence lie in the same plane. Second law, the angle of incidence is equal to the angle of reflection. It is given by I is equal to R. Refraction. When a light wave passes from one medium to another medium, there exists a change in direction of a light wave is called as refraction. First law states that the incident ray, refracted ray and the normal at the point of incidence lie in the same plane. Second law states that the ratio of the sine of angle of incidence to the sine of the angle of refraction for any two given media is a constant. Therefore, sine I by sine R that is equal to constant. In another way, we can write that sine I by sine R that is equal to mu. Mu is nothing but a refractive index of a medium, constant. Total internal reflection. When a light wave is completed reflected while it travels from one medium to another medium, then this phenomena is called as total internal reflection. It means when a light wave passes from denser medium to rarer medium, the total light is reflected in the same medium. It is called as total internal reflection. So there are two conditions to achieve the total internal reflection. They are light should travel from denser medium to rarer medium. The angle of incidence should be greater than the critical angle. So in case 1, we can see that angle of incidence is less than critical angle. So the reason refraction takes place. In the case 2, we can see that the angle of incidence is equal to critical angle. Therefore, the light waves flow on the same plane. In case 3, we can observe the angle of incidence is greater than critical angle, then the light waves reflected in the same medium, that is nothing but denser medium. So this one we can get from the Snell's law, n1 sin pi c that is equal to n2 sin 90 degree. So from this, sin pi c is equal to n2 by n1 sin 90 degree. Therefore the critical angle pi c is equal to sin inverse n2 by n1. Interference. The interference is based on the superposition principle, which stated that when two or more light wave trains act simultaneously on any particle in a medium, the particle is displaced due to the superposition of all the wave trains is called as interference. In another way, we can explain the interference. When two light waves from the source superimposes on each other, then the resultant amplitude in the region of superposition is different than the amplitude of the individual waves. This modification of a light energy is nothing but interference pattern. So in general, There is a condition to achieve the interference. There must be two sources which are coherent in nature. The source should have constant phase difference or zero phase difference. The sources should be closer to each other and the distance between the sources and the screen must be larger. For the constructive interference, for bright fringes to appear, the path difference between the two waves which are interfering should be equal to n lambda. That is given by path difference is equal to n lambda. For destructive interference, to get the dark fringes, the path difference that is equal to 2n plus 1 into lambda by